personality choice. It's too creamy.
Okay, I think it's close enough. We're going to keep going. So we can shut the back door. I would appreciate it. First of all, welcome everybody back to session number 2. Just want to thank our sponsors. Without them, this wouldn't be the event that we have. So I just want to mention them: Lakeland Trotter, High-Five Development Services, TP Mechanical, Weigel Energy Systems, Siemens, and Scansia. So I'd like to welcome our second set of breakout sessions. Bob Moretti and a returnee, John Breidenbach from Tremco, and David's going to come in and do a little more introduction. So welcome, and everybody enjoy.
Thanks, Jerry. As I said, I think quite a few were in the first one, I'll just recap. So we've been really honored to be a part of this for the last 10 years. This is the instance that should have been the 10th year because we took it off here last year, but we've been a part of this from the very get-go, and I think commendations we had to go, because this has always been about education, right? It's about trying to educate and help everybody understand a little bit more about what a high-performance building envelope looks like. That was the original genesis for this back 10 years ago. It was about building performance into buildings, because we know that performance yields benefits, both to the individuals within the building, the organization that operates the building, and the community outside of it. So our first presentation this morning was on the vertical pieces of today. This next piece is going to be on the horizontal today. So Bob Moretti is Director of Technical Services from Cleveland, from Tremco. Lives in Chicago, but operates out of Cleveland. And John Breidenbach, who you met before, who is a registered architect, kind of brings the design professional conversation to this. So we're going to talk about some things that might be common knowledge, but we're going to dig a little bit more in depth into that. But we're also going to talk to you about some things and show you a couple of things here that historically have been problems that we're trying to be solved. So a couple of unique pieces here that hopefully be of value to you. Thank you for joining us.
Dave, thank you. Thank you, all of you, for joining us. This is part 2 of a little mini-series we're doing on, really it's about sustainability. And what we're doing is we're talking about the existing construction, the as-built environment, if you will, and sustainability. We're focused for both the presentations, the first one on the vertical components and how the roofing, on topics such as durability. We'll touch on that because we spend a lot of time on restoration. We're going to tag team this presentation. Bob giving the manufacturers, contractors kind of viewpoint, without bringing an architect's viewpoint, having been in a position for 25 years where I represent a manufacturer, but I partner with my design professionals to make sure that we fulfill their design intent. So as we tag team this, hopefully we'll do a good job and give you a clear idea of how sustainability can be achieved through durability and also restoration. So what we're going to do is we're going to talk about roofing, and obviously, and how the roof may start leaking, how may develop issues, and we're going to look at some of the sources of those. We're going to talk about restoration, the state of affairs with restoration today, and we're going to talk about why restoration can be so important to those who are responsible for buildings, or design professionals who have accounts, who have long-term buildings that need to be managed. We're going to touch upon some of the technical advancements that are going to happen in the field sometime soon. Bob's going to spend time with that. And frankly, it's kind of exciting what could be happening with the world of restoration. I tell people it's about as exciting as it will get, really. So it's kind of some fun stuff. We're also going to talk about added drivers as to lately with pandemic and material shortages. Again, why restoration comes to the forefront as a very good solution for our building owners and you all in taking care of existing buildings. So, if Bob and I do our job right, which I did 50-50, at the end of this, you'll have hopefully a better concept of how to identify intrusion issues in roofing, maybe where to look for them, and maybe it's not the roof. We'll touch upon that. We'll talk about historical obstacles to roof restoration. Came up with an idea, but no, we're not going to do it. We're going to dissect the current massively disrupted roofing replacement material supply chains. Roofing, and I don't want to steal any of Bob's thunder, has found itself in a position that is not very good with supply chain issues. We are directly impacted by material shortages and supply chain issues. And again, restoration may be a solution to that for you. We're going to explore what both of these well-established approaches offer as far as restoration, and we'll also be touching upon durability as we discussed. So, first of all, I've been around Tremco for 25 years. You've been around Tremco for 10 years now.
Just celebrated 10 years.
And you've been around just 5 years? Or 25, I'm sorry. All of us, the point is, we've all spent a lot of time in roofing, walking roofing, looking at roofs. Our first job when we came to this company was go find a roof leak, go find a problem with my roof, find the source of it. And one of the things that often happens, and this ties right back into Marcy's presentation, is sometimes the leak in the building is not the roof, it's the perimeter conditions, peripheral conditions. It's the wall, it's the coping, it's the sealant joint, wall system, curtain wall, on and on. Mechanical unit that the guy left the door open on. That kind of thing becomes the roof leak, right? So we get into this kind of thing all the time. But what it takes is a comprehensive knowledge of how buildings operate, how building enclosures work. That's why I say, as an architect, roof restoration belongs to architects. You can't do roof restoration without knowing how the entire enclosure works. Who knows that better than anybody? Architects. That's why I love partnering with architects when they get into this kind of concept. Because you get it, you understand it. So, just get off my soapbox on that one. So, roof restoration, not a new concept, but certainly one that's come back to the forefront. What are we used to? What are our buildings owners telling us they want to do? Replace, patch and repair to keep it alive. The roof we're talking about, of course. Replace again, patch, repair, replace. This endless cycle of expense and disruption. And let's talk about the sustainability narrative of taking vital roofing materials and taking them to the landfill, and that's it. That's what we're used to. What we're really interested in is restoration and breaking that cycle, assessing the existing conditions, and doing it in a very regimented way. We'll talk about those steps. I'll walk you through those. Patch and repair, because we've got a roof that's going to be restored, but you can keep it alive for 5 or 10 years through patch and repair. And maintenance. We should probably roll that in as well. Get the roof to the point where it's reached the end of its serviceable life. We establish the proper way to take care of it, and we restore that roof, put a new full system warranty upon that roof. That means, when we talk about restoration, full system warranty. Everything from the structural deck up falls under that new warranty, 12, 15, 20 years, what have you. We maintain that, we assess it, and at the end of that restoration serviceable life, we oftentimes get the opportunity to restore that restoration, which takes less material and less time. And we broke the cycle, entered into a new cycle, where economy is far better, where things last much longer, durability, sustainability, all are in play. Okay, so roof restoration. How many folks have been involved in roof restoration, by the way? Outstanding. Okay, fantastic. This is great. Usually it's not my hands, I'll be honest. Candidates for roof restoration. Which roofs can be restored? Which types of roofing can be restored? Surprise, all of them. All the roofing out there, generally speaking, can be restored. What is the key to restoration, though? What is the most important thing we talk about restoring a roof? Anybody want to take a swing at that one? No? Okay. Establishing whether a candidate can indeed be restored. All of these types of roofs can be restored, but we need to look at the individual candidate. So very, very important. We have to do it in a knowledgeable way. And here's the other part. When you're a design professional, you're entertaining this idea of restoration, you need to do it in partnership with a manufacturer who's going to match your expectations as far as system, full system warranty, on and on. So the diagnostic process, it's, like I said, it's relatively regimented, and it's the same, nearly the same for all types of roofing. First of all, we want to do the visual inspection of what? The roof? No. Nobody needs the roof. Let's go inside. Let's look at what's going on underneath. We remove ceiling tiles, look at the structural deck, fastener type. Are there enough of them? Are there any leaks? Part of this interior inspection, though, is also talking to the guy who managed that building. What do you have on this roof for entertaining restoring? You have drawings, lead calls, specifications, all that material we want to know. Because you've got to give it to your manufacturer because they have to be at peace with the candidate because they're going to put this full system warranty on your solution. The other thing we want to check out too, the picture on the my upper right, safety. Take a peek at things, make sure it's safe. Sometimes they're not. It's a real picture, a real situation, so it does happen. So be mindful of that. Looking at the membrane, then we do what architects do. Get our grid paper and our tape measure and all that good stuff. We want to locate all the penetrations. We want to locate drains. We want to do a roof plan drawing. We want to know detail types. We also want to begin to take into account what's obsolete, what's not working, what problems are there that are obvious that need to be addressed as I build out this project manual or document set. Then we want to get into core sampling. Core sampling, anybody been through the core sampling process? Maybe you've been through it with Dave. Even though the building manager gave me a specification and drawings, we're still going to do a core because, you know, surprise, surprise, sometimes the existing conditions don't match the drawing. It does happen, I'm just going to tell you. So we want to make sure, we want to check what's up there, the condition of it, all that good stuff. Then diagnostic testing. Diagnostic testing is the most important part of the diagnosis. What we want to do in this portion is establish if there's wet or water-laden material in this roof. Very important. We want to establish this because if we're looking at a roof and it's 10% wet and the setup is relatively simple to get to that roof, taking that wet material out, putting it back in kind before we restore it makes financial sense as compared to replacement. But if it's 100% wet or 90% wet, it may not. It may be a goner. So what this does, this diagnostic process of getting to how much wet material is in the roof, puts us in a scenario of understanding the business model for this particular roof system. Very, very important. And I'm going to talk a bit more about how we do this with infrared, nuclear, and capacitance in just a second. And frankly, I could do an entire hour on that and maybe do an additional hour. So it's deeply technical, but we'll make it fast. And of course, once we talk about, we figured out what material is in the roof, we have to remove it, picture lower left. We have to remove it, replace it in kind. There's taper, we need to match slope, it's got to be compatible. Because what are we doing with this existing roof? Actually, what are we doing? What's the simplistic thing that we're doing? We're building a substrate to put the restoration roof system on. And it has to be clean, has to be performing at a certain level, because we employ that existing roof in terms of waterproofing and R value, tensile, and all the other good stuff. It's got to be a proper substrate. We're building it. Okay? Infill repair, and then we prep that roof in various ways. It could be power washing, it could be scrubbing, a little scrubbing, sweeping of old gravel and flood coat and things like that material off of the roof, all that kind of thing to prep the existing membrane. So these diagnostic tools, there are three of them that we lean upon heavily. The one we lean upon heaviest is infrared analysis, or thermography. Anybody been through a thermography or infrared analysis? Okay. I didn't see enough hands, so I'm going to give a real quick definition. 3. Okay. Infrared. How many people here saw the show Cops? Oh boy. Okay. My metaphor's not even going to work. Wait, Cops. I said Cops. How Chicago? Anyhow. Cops. Helicopters flying around looking for the bad guy at night, right? Black and white, right? Did I say cops again? The bad guy shows up black, the white in the background is black, he's readily apparent, because they're using infrared technology. They're using forward-looking infrared to find that guy. They're looking for heat signatures, okay? That's all it's finding, heat differential. We do the same thing with thermography. Picture upper left. At night when the sun goes down, the roof has been heating up all day in the sun, okay? The moment the sun goes down, the source of heat goes away, dry roofing material shed heat immediately. Okay, it's gone. Wet materials hold on to heat. So we use that same technology, and we're able to see exactly where wet material is in a roof. Okay, so really handy. I mean, it's accurate, done right with the right camera, by the right operator, on the right roof system. A lot of caveats. So what do we do to make sure? And I know Dave does this as a matter of course. He brings in nuclear, which is the picture on the lower left, which sounds scary, but it's not. Nuclear gives us the capacity to read essentially the amount of hydrogen in the material beneath it by shooting down neutrons and then bounce back up. And that proportion tells you if the material is wet or dry. Okay? So it's a way to do an infrared and we can check it with nuclear. Capacitance meter, it's like a lawnmower, a yellow lawnmower, right in the middle, actually has two electrodes. One electrode shoots out a charge to the other one, and through that reading of the amount of energy that does or does not come through, that system can tell you if there's water-laden materials, not having actual water in the material. It's another way to find out if materials are wet or not. Okay, so the important thing is this. There's a lot of variables in doing these types of diagnostics. So, and you really want to check yourself by doubling up your system. Always smart. But back to infrared. A lot of guys I know said, you know, I'll do my own infrared. I got on Amazon last night. I bought an infrared camera for my iPhone. It was $200. And I've got one. They're cool. They're cool. They're not so accurate. Okay? There's a whole spectrum of cameras that exist in the marketplace. The picture on the upper left, one of our in-house tomographer uses it. It is one of the best. And it uses, yeah, I know, I showed you a little bit. The mid-wave camera actually reads far more effectively, far more precise than the long-wave camera. The cheaper cameras you can buy, anybody can buy and use, are not as effective or accurate. So the point is this: when you work with somebody who does your infrared analysis, it's got to be somebody who really knows what they're doing, but they also have to have the right equipment. They can't have an infrared camera attached to an iPhone. It's just not going to help you out. And there's actually an Infraspection Institute that qualifies all these things and will offer up all kinds of information to you should you be interested or have trouble sleeping at night, and tell you about how a camera can and cannot affect you, or how it can help you or cannot in certain instances. Okay. Another diagnostic tool. Yeah.
Just to give you an idea, so the add-on device to your iPhone, that's $200. Camera that was in the middle is $80,000. So the big spectrum. You can go out and buy a $500 camera, you can buy a $1,500 camera. They're all good cameras. But I will tell you, there's a reason we use an $80,000 camera instead of a $1,500 camera, even a $5,000 camera. So just without going too deep in the weeds, they're really, I mean, stuff is fun technology. All it really sees is temperature differential, but you got to know why you're seeing what you're seeing and when you're seeing it to see what you're really trying to find. Because in the end, all you're seeing is the radiant temperature that's coming off. You're not seeing into the membrane. You're only seeing what temperature is radiating off, and then you got to understand why. Is it going to evaporative cooling? Do we have a differential heat load? And depending on the construction, you may be seeing temperature that's just retained, but you're not really seeing the insulation that's wet that's holding the heat. And so that's why you want to have these multiple types of technologies to help you confirm, because I will tell you, after 35 years, we've been on the rooftop where we thought we were seeing wet. All we were seeing was just so much latent heat that was still residual within the roof system. We were not waiting long enough for the roof to cool down. And that's where the other technologies come into play. So there's a reason that there's a spectrum. They all have their place, but we're really on one end of the spectrum if you really want to get good data.
That's right, absolutely. So a really good operator infrared camera knows how roofing goes together, how a heavy flood code could impact a reading, how wind could impact a reading, humidity, on and on. There's so many variables. It takes the right camera and the right operator. Next thing I want to touch upon is when we're looking at asphaltic-based roofing, built-up roofing and modified bitumen roofing, multiple ply asphaltic systems. We want to, again, make sure that we've got enough meat left in the existing roof to actually restore it. So we want to check for some things. One of those is tensile strength. And there's an ASTM for that, ASTM 2523. We take a certain size core and we pull it to see how much tensile is in it. Not in just machine direction, how the rolls roll out, but also cross machine. And we're looking for 200 pounds plus in tensile of the finished roof system. We also need to check the amount of bitumen in these systems as well. So if you think in your mind, I've got an old modified or old built up, this might work. We really want to check those to make sure we have the tensile and the amount of adhesive or bitumen left in the system to actually restore. Because we're employing that existing roof as part of the new warranted long-term system. Very important, we know exactly what's going on. Next, I want to touch upon the cost of neglect. And Dave, I would love you to chime in, because this is something this is a project that's near and dear to your heart.
Yeah, can't talk about the climate, but we talk about all this.
Yes. So when we do an infrared, and the architects, I think, will appreciate this, you should get from your folks a drawing, and it should be EWG, so you can load it right into your set. That shows exactly where the wet material is measured out, quantifiable, take off sheets or whatever. It's also nice to have, I don't see it here, but I like a spreadsheet that shows the roof area and then the amount of square feet that's actually wet, because then you know the size of the roof, the amount it's wet, and you can begin to put those numbers together. Is it restorable or is it we're going to replace it? Not one of these slides. One of these slides is say, you know what? Figure out when you need to do restoration, plan for it, and you probably want to do it when you establish a budget to do so, because when we just let things go, this is a before infrared. This was the 4-year timeline between the first survey that was done and work was enacted on, and here is the second. So the first infrared analysis.
Well, before you do that too, I will say that while we've been doing this for 93 years and we've got a pretty good understanding of where things are in their life cycle, we don't have a perfect crystal ball. So sometimes, when you talk about restoration, there's a window of opportunity, and it's not indefinite. There's a period where you're in the window. What I can't tell you is when we step past the window and we fall off the cliff. And what you're going to see here in a minute is a couple of roofs that not only did the wet grow, but suddenly a roof went off the cliff. And I had no way of telling the client when it was too late. All I could tell them was that there was a window and they needed to move, and they didn't move fast enough. And when you look at the wider, the bigger part of the roof on the right-hand side, you're going to see a roof that was going to light up here in just a minute.
Yeah. I'll go ahead and hit it. So this all suspense. So
see the difference? So this was a roof, and I said, I'd be able to restore. Go back to the slide before them. It fell off the cliff.
And Dave, I don't know if you noticed, but in my travels, when problems do occur on a roof and they begin to decline, it accelerates. Every time. 2 to 4 years.
4 years. So some of the roofs, the areas grew and wet. So before and after, you can see like the kind of middle on the right there. John, go back just for a quick second. You'll see the ones on the right, the two from the lower ones in the middle. All right, they were wet, but then 4 years later, the wet areas had grown. Right. And then you can see where the upper one just blew up, and then the one next to that started to have problems. So diagnostic tools can be really informative to help you get a lot of quantitative data. Because when you're just looking at understanding construction, the condition, it's more visual and kind of that nature, but there are tools that you can use that will really help you quantify where you are in the process.
Dave, thanks. Okay, so let's say we've got a candidate. We skipped that part where it got all wet. We're actually going to restore this roof. How do we restore it? What is the best way to restore a roof? Well, it seems that fluid applied roofing systems give us a huge advantage when we talk about restoration. These are just some pictures of fluid applied roofing going down. But a fluid applied roof, have anybody here installed a fluid applied roofing? Fluid applied air barrier? Marcy, great. Okay. Fluid applied gives us a huge advantage from just a roofing standpoint. The performance criteria of these systems is extraordinary. We like to think of it as the next level of roofing. Yeah, thank you. The roofing goes down in liquid form. There are no laps, no seams. It configures to any profile. We can reinforce it or not reinforce it. If we don't reinforce it, we obviously have a shorter term installation. But if we reinforce it, we get into 20, 25 years of life from these systems. And what they look like going down, initially we want to do the flashings and laps. And we do a 3/4 application of this material of fluid applied, laid reinforcing, and a top coat of fluid applied system. They're polyurethane typically, they can be PMMAs, they can be UMAs, they're using silicones, not anymore because China shut that down. But we have a lot of different chemistries to choose from based upon different compatibilities out there. So this existing condition or existing roof begins to inform your selection of what you want to use for a restoration memory. It's a high build application of material. It's not a coating. This is not even close to coating. These are standalone roof systems that go down from 32 to over 40 mils in thickness. And the reason for the base coat and then another 32 or 42 mils for the top coat, the reason that there's a picture of a penny up here to give you an idea is a penny's 50 mils thick, a dime is 40 mils. Okay? If you've ever worked with single ply, you can handle like 45 to 60 mil ply. So we're putting down an immense amount of material onto the existing roof, using that as substrate to build this new roof on. And we warranty the entire thing. This is where the industry is shifting right now. Bob's going to get into more of the whys. But this is what's happening in the industry with existing roofing. We cannot replace roofing like we want to. Shortage of materials, the cost, and everything else. Restoration can oftentimes be one of the best solutions you can bring to your owners. Just make sure you work with manufacturers who give you the full system warranty and the minor hit as you go through the diagnostic process. So why restoration? Obviously stands to reason. There's nothing much more sustainable than keeping existing buildings in place for performing longer than initially conceived. Great sustainability narrative on that. We use existing assets instead of having to put into new materials. Minimum disturbance of ongoing activities. These restoration projects tend to be shorter in duration than replacement. And if we're not removing a lot of material, oftentimes we can restore a roof with some of our lower odor materials that exist in the marketplace, and folks don't even know we're there. And we effectively restore the roof, provide a full system warranty while ongoing activities are going on. Contractor friendly. Detailing for this, just to touch upon this with an architect. Detailing for fluid applied is very, very simplistic. Prime and prep the surface, putting your base coat material, reinforcing, and top coat. That's your detail. Base flashing, pipe penetration, gravel stop edge, what have you. The detailing is very simplistic. So it really gives us this next generation opportunity as far as roofing is concerned from an installer standpoint, because they're not so concerned of training their journeyman how to properly do a single ply roof, or God forbid a full-on pitch pan on a built-up roof or modified. Installation is far more simplistic. The key is preparation, prime, and mill thickness. As long as we get those things dialed in, these systems go down relatively uneventfully. And I'm finding that, generally speaking, the contractor base across the country has really embraced this and run with it. The warranties, of course, we touched upon. We're looking at full system warranty. If you want to work with somebody on this, they're only interested in putting a warranty on what they're applying, probably not a good solution for you. It wants to be full system. The restoration, it says here, I always check for a local rate source, 33 to 50% the cost of replacement. Is that whole true?
It is, there's more complexity, but it gives you a guideline, saying the idea is that if I can drive another 20 years of service life for somewhere around half the cost, I've doubled your impact on your money, right? So most people have more need than they have budget. And so if we can drive another 20 years of service life for half the cost of the roof, off replacing it, and that's good value. Most owners are really interested in hearing that. And the more place, all of those will drive the delta even broader to say, not only is it cost effective, but I'm also less operationally disruptive to your world. So you won't hear me, you won't smell me, you won't see me. This budget is going to take it off and start over. So it's a lot of good reasons. In the world that we're in right now, from a supply chain perspective, the roofing world is in the catastrophe, and I mean that literally. Our supply chain world has been catastrophically disrupted in a manner that in my 35 years, I've never seen anything like this before. We've got materials that we are now forecasting 12 months out, maybe. Maybe. There are parts of the world that are still shut down. There are parts of the world that live differently than we do. They live 10, 15, 20 to a home. They all go to the same factory. When one person gets sick, they all get sick. We can't get stuff out of other parts of the world. If we get it here, it sits on a dock, it sits on a boat anchored off both the coasts, because I don't have people to get the material off the boat, and then I don't have truck drivers to drive it somewhere else. And then the ripple effect. So we live in a global economy today that we have now seen disrupted in ways we would never have forecasted to have seen. A little virus, not just a localized event anymore. It has pointed out the realities of a global economy, interconnected on a global basis, in ways that we would have never foreseen. In our world, from a roofing perspective, it's just about as upside down as we can get. Most of our suppliers have declared force majeure. You know, from a contracting perspective, that means I no longer am obligated. An act of God, right, has interrupted my world such that I can't meet my pricing commitment to you, I can't meet my production commitment to you, and I'm now protected. I'm out. The contract is broken, you're on allocation. In many cases, the price of the material is going to be what I say it's going to be when it leaves my dock. If and when. And by the way, you're going to get 10% of what I was committed to getting to. You're going to pay what I tell you you're going to pay, but not I'll go somewhere else with it. That's how upside down our world is. And so, trying to replace the roof now is hard. It's almost impossible in some instances. So, when I envisioned this presentation a year ago, I thought, okay, but I would not have dreamed that it would be as disruptive as it is today. And it's getting worse, I will tell you. And we're not going to be out of this for probably a year or two in my mind. This is not going to go away next spring. This will be with us through all 22, and I predict that it will be with us through all of 23 in some manner. Because we can't even get caught up. The raw materials that we use in our world can go to so many other places that, and there's so little of it, that it's just we can have it in our energy. So, you know.
Exactly. So I gave you the traditional reasons that one may entertain restoration. And lately, as Dave alluded to, we've got other drivers, as I mentioned in the bottom here, that Bob's going to focus upon, that make restoration even more viable, more than it ever has been, at least in my 25 years. I did want to touch on one last thing before I leave you to Bob, and I want to give Bob plenty of time. Sustainability.
Thank you, Joe.
Thank you. Sustainability. Roofing and sustainability. We oftentimes think about roofing and sustainability, vegetative roofing, or photovoltaic systems. Those are really awesome, sustainable installations that we all love, but they're massively expensive. I would submit to you that there's nothing more sustainable than roof restoration, because we're keeping existing building components in place operating longer than they really should have. That's sustainability at its base. And we can put data to that. You should work with somebody on this. They should be able to give you some data to kind of back this up a little bit. This is an example of one of the analyses that can be done when you look at roof restoration. What are the benefits of doing roof restoration over replacement? We have such things as the amount of tonnage of material that's not taken to the dump, or the number of dumpster loads and dump truck loads to the dump. All this kind of thing is knowable, measurable data that can be provided to you and then to your client to kind of solidify the idea from the point of sustainability and all those green initiatives that everybody adheres to. So just want to touch upon that. Bob, I give the mic to you.
Cool, thanks, Jacob.
So I apologize ahead of time, you guys had to put up with a couple things. Chicago guy, Italian, you saw the name, so you can see me doing more of this. Try to get excited, but keep that tone down. And the accent as well. So JB and I know because we live in Chicago, but we'll ask David since you're local here. Is it rough or rough? The great debate continues, right? Yeah. So I apologize ahead of time for the accent. And please, I know we're going to take some of these slides a little quicker than others, but if you have questions along the way, stop me. We did leave some time at the end. Please stop me. To go back, kind of give you a sense of my journey here at Tremco, this will help you understand where I'm coming from today as a speaker. So the first 2 years I was at this company, near 10 years, I was an architectural representative. So I met with design professionals all over the Chicago area every day, helping them serve their clients, right? Through a lot of the things that we're talking about today. I then transitioned into a field technical role where I was a roof advisor. So what does that mean? You heard these guys talk in the presentation before, if you were here, about someone who stands on the roof and makes sure that here are the plans and specs, here's the roofing contractor working and connecting those. I'm affectionately known in Chicago as the Tremco ODCF, and I wear that with a badge of honor because I'm literally on the roof making sure that it's going down properly, and as a manufacturer, I can shut the job down by quickly, right? Usually doesn't get to that point. But I'm really proud that sample there, that's my running the equipment, I cut that, right? So you want to hear from somebody who's actually done it and been out there in the field and did the testing, I'm in person. Okay, so to speed up here. Here we go. So what's going on in the industry from a restoration standpoint? What's possible, what's not possible? Okay, again, I've been doing this for 10 years, David's been doing this 35 years, so when we were talking and putting these slides together, you know, really in the past, what have been the two biggest hurdles? Like, why couldn't someone restore a roof? And you heard a little bit about it with the diagnostic discussion, but it's either too wet or too weak. Traditionally speaking, those were the two main hurdles. If the roof was too wet, or if it didn't have enough tensile strength, it was unable to be restored. And hey, we gotta replace it. We don't have the right information here, the right data, time to replace. What's different now? What's changing? This paradigm shift. The ability to dry out a roof exists. I promise you. And you're going to see a video for that here in just a second, right? And I'm going to share with you some data that goes back to 1981 from a report that was written, a white paper about roof drying, roof venting, right? So the information has been around since before I was born. And for whatever reason, people choose to ignore it, but it exists. And now we're talking about it at the next level. Also, this reliance on the existing membrane from a performance standpoint, right? So you heard JP talk about it before. It's transitioning from the restoration system being highly dependent on the performance of that roof, hence all the diagnostic testing that's done on that asphaltic roof, to it just providing a sound substrate. Because the materials you're putting above it have the ability through technology to elongate, also provide new tensile, provide all these like kind of superhuman characteristics. So that's really the big shift that's happening right now. So what does that mean? What does the 2.0 version of restoration look like? If we're talking about a gravel surface roof, whether it is a modified bitumen roof or a traditional built up with asphalt plies and fiberglass reinforced, again, you're basically putting down like a leveling coat. And the technology that's very common is a polyurethane, right? So if you think about it, you're using that existing roof as the sound substrate. You still have to fix the deficiencies, right? Because in order to provide a sound substrate, you can't have insulation in there, right? But now the concern isn't so much what the tensile strength of that roof is, or at what point does it start to bend and break, because you're really isolating it down by itself with all the additional waterproofing that you're putting on top. Okay? So you can read the bullet points there for yourself. I just want to point out the fact that when you think about an old school 3 or 4 quad built up roof with flooded rock on top of it, that is a huge chunk of waterproofing. So with the leveling coat and with the restorative fluid that goes on top of it, 400 to 500 pounds. In other words, you talk about the dimes, so that's what, 10 or 12 dimes stacked up on
25 sheets of paper. I mean, that's how much waterproofing exists in the system. Let's talk about this whole idea of roof drying. And if someone really wants to read the article, I can send it to you. You can read it this weekend. But again, this study that was done, like I said, in December of 1981, and the title of it, Can a wet roof insulation be dried out? So again, I'll just kind of give you the clip notes for it. Mock-ups were assembled in the state of New Hampshire, and they put different breather vent systems on them. I don't know if anyone's ever walked on a roof where you've seen those little breather vents. They're designed to dry out the roof. Keyword being designed to dry out the roof. Do they actually dry out the roof? That's what the authors set to figure out. They used one-way vents, two-way vents, multiple two-way vents, solar-powered vents, membranes that they were told to be able to breathe and vent, and edge details that would also breathe and vent. Guess what they figured out? Spoiler alert. None of them did a damn thing. Like, literally did nothing. It would take decades. If you look at the table in the report, the longest one is 60 years to dry out. The shortest one, the shortest combination they came up with was two-way vents in an area. If you're creating cross ventilation, they were able to take it down to 13 years. So the authors concluded, if you read the conclusion statements, basically those systems are completely ineffective. Okay? And furthermore, if you have a roof that doesn't have a vapor barrier, so you think about like a traditional roof with a steel deck and there's nothing preventing vapor from going in and out, we call this the self-drying roof. Because vapor drive most of the year in most parts of the country is going from the outside in, right? If you put one of those breathers on a roof like that, you're actually creating a bigger problem. Right? So it changes the whole dynamic of it. So, he started playing around, believe it or not, with a vacuum cleaner. Sounds silly, but like, hey, let me throw my Craftsman shop vac up there and see what's possible. So he drilled a hole, stuck it in, sealed it, ran it to a drum, put a fan in the drum. Look at the results. After 134 hours of operation, they removed 110 gallons of water from that 180 square foot area, taking the insulation back to 83% of its installation point. In other words, you can dry it out. And they're talking right now, the insulation that was used, they used perlite insulation in the study and fibrous insulation, glass insulation. So glass insulation is pretty permeable. It's easy to pull stuff through. We'll talk about polyiso here in a minute. With the facer, not so much. So there's a tremendous amount of suction that has to take place for it to occur. But what's also interesting too is they came back a year later after this, and they found that they didn't fix the deficiency in the roof, so the roof had gotten wet again. So they hooked the vacuum cleaner back up, sealed the leak this time. When they came back the following year after that, they had that 83% number back above 90%. So it is possible to bring materials that were once thought to be kaput back to life. So for 3 minutes, this video on the left is going to play, and again, this is explaining in generic terms what the technology is that I'm just speaking to you about. not so easy to pull through. So I think the analogy we used was like we're trying to suck a brick through a straw. So it takes a little bit of time, a lot of energy, but it can be done. On the right, you know, JD spoke about preparation. Preparation is key. And I think in a lot of jurisdictions, I'm not familiar with your local jurisdiction here, but the days of a roofing contractor being on the roof with a power washer and putting all that crap down the drain is pretty much stopped, right? So you have to be able to prepare the substrate in a manner that meets local guidelines. So having an organization that can basically come out and collect 100% of the water that they generate on the roof and drinking water. That's getting to be a big thing, especially where I'm in Chicago. So David gave a really good insight as to. No, you're totally fine. Because again, 10 years in the industry, 35 years. So we are really on rough terrain right now, uncharted. Okay? And there's a lot going on. It really is that movie The Perfect Storm. It's happening right now, whether you guys have seen it or not. So first thing, containers. Okay? Just read an article last night. As we sit in this room off the coast of California right now, there are 500,000, 500,000 containers sitting on ships. And they cannot come into the port. Why? Anyone know? Why can't they port? Yeah, labor problems. 60 to 70% capacity in port. Port workers don't work on Sundays. Some ports have thought about going to 24-hour shifts. Nobody's been able to figure it out yet. So you're working with pretty much one hand tied behind your back. Not to mention the fact that these mega ships, they call them, which there's 19 of them sitting off the coast right now, you're talking about ships that hold up to 20,000 containers. I mean, that's insane. And the size of boats they're predicting is just going to be bigger and bigger and bigger. So it's awesome, we can put more stuff on a ship, but when that ship clogs up the Panama Canal, we have a really big problem because there's a lot of stuff on it. Okay? Crazy. Okay, so not to keep going down this hole here and paint this dark picture, but I'm going to have to driver shortages with trucking. You know, we're seeing surcharges where you're paying 4 or 5 times the amount for a flatbed truck than you did just once. I mean, all the power is basically shifting to the drivers. That's totally okay, but if someone doesn't want to come pick up your load for $5,000, you put it out there to bid for $10,000. You still don't want to get $15,000. You just keep going and going and going. And that trend is going to keep going. Right? There's really no end in sight. My brother back in Chicago has been considering becoming a truck driver just because of the demand. It's pretty much, they'll take anybody. If you want to drive a truck, let's go. Raw material shortages, and I'm assuming most of you in some way, shape, or form have had a project with polyiso insulation on it in the last few months, so you know what we're talking about, right? The primary raw materials, MDI and polyol, used to make those materials are having some major issues. Most of the world's production of MDI is in China. So there's that whole thing going on. Polyol is typically made in the Gulf, in Texas. You guys may remember earlier, sure, there's an ice storm that came through and annihilated parts of Texas. Here's the real problem. When those plants go into shutdown mode, there's a sequence of shutting everything down properly. That didn't happen. So it's not like they could come in the next day and fire all the machines back up and say, hey, we're ready to make more polyol. Didn't happen. Thus, further delays. And the FDA, we had to put this in here from your macroeconomic economics course. The supply curve has shifted, so obviously price is going up. Couple that with the demand curve shifting this way, and your new price, P3, is way up there. Way up there. I'm just curious, what's the biggest increase you guys have heard of in materials, percentage-wise, in price? 10%, 20%, 50%, what are you guys hearing? The biggest one I've heard today was with low-rise foam insulation, it went up 200%. Just like that, overnight. It's a reality of what's going on. And again, I'm usually a pretty like glass half full guy, so I'm sorry I'm giving you the empty spiel right now. But couple that with what's going on in the environment. And I know what you're thinking, but I promise you I don't know how to use Photoshop. SAP, I'm good, AutoCAD, I'm good, Photoshop, not so much. That is a picture just south of Panama City, Florida, after Hurricane Michael came through in 2018, which by the way is too big. What's different about that structure? Well, spoiler alert, it was built with ICF. Okay. So now you have these environmental challenges where in order for us to be able to restore a building, it has to be standing for 20, 30 years from now. So that's changing the shift, right? We have to build more resistant buildings. Show of hands, who's worked with a client that's out there insured? Factory mutual insured. Anybody? Okay. Pain in the butt, right? Huge pain in the butt. Just real quick, what am I talking about? FM Global Insurance requires that their customers put systems on their buildings, specifically roofs, that have been tested by their testing affiliate company, FM Approvals, right? So you came to FM and you said, this system is UL tested, and it's tested for wind via FM, whatever, 4474. What was it tested with FM Approvals? Is it in the roof map database? If the answer is no, you get a big fat red stamp. No, I don't think so. Okay. So what's changed over the last few years with that map? Well, everything that's in green on that map is moderate hail, which is basically taking a 2-inch ball and dropping it from 81 inches above the surface, okay, to see what kind of damage it does to the roof during testing. Everything in pink is severe. That's taking the same 2-inch steel ball, but now I'm dropping it from 7 feet above. Right? The last one there, the dark pink, very severe hail. If you've ever seen this test, you can look it up on YouTube and probably find a video. It's pretty cool, actually. You take a 2-inch ice ball, you put it into a gun, and you shoot it at 150 feet per second at the roof assembly, at which point it basically explodes. You do that 3 times in different spots, and by the way, they pick the spot that's over the fastener for a reason. And then they take it out of the test chamber, they see if it's cracked in any way. And when I say cracked, it means the membrane won't border insulation. If it's cracked, it's a very rigorous test. So, what am I saying to you? If you were working with a client in this area of the country who is FM insured and they were doing a roof replacement project, that is the standard that they would have to abide by. Pretty crazy, right? So things are getting more and more challenging. At the same time, what hasn't changed, right? There's a lot of stuff that, again, you go back and look at historical documents. It was good practice then, but it's still good practice now. And that's this whole concept of the NRC saying, beware of warranties. Specifically, we're talking about warranties. Why is that? There's some bullet points there on the left that explain that, particularly number 3. There's restrictive provisions, which are also referred to as exclusions. Every warranty has exclusions. Okay? Basically, the NRCA's opinion is still the same, such that you pick systems based on performance, right? Quality of materials and performance. The warranty is just an add-on. If you put systems side by side and your primary selection criteria is the warranty, and you say, well, this one's got a 25 MDL, this one is 20-year prorated, so obviously this one's better. You're approaching it the wrong way for the NRCA. Okay? And I'll give you a $20 Starbucks card for anybody that can answer this question. Who writes roof warranties? The actual documents. Who writes those documents? Where do they come from? You're very, very close. I'll give you a 10 and 10. The attorneys of the roof manufacturers. That's the honest to God's truth. Right? They're not there to necessarily protect the customer. And I think that that's something that's often overlooked. So again, I think everyone in this room, and a lot of hands who've done projects before, I think you're all aware of this. Again, it hasn't changed since I think this was published in 91. Now take it really back, old school, 1974, the MBS 55 study, which is where this whole ASTM 2523 came from. So just to kind of speed this up a little bit, the study back in 1974 basically just said what the NRC just said in 91. Pick materials based on performance. This ASTM 2523 is important because it's the tensile strength, and JD said machine and cross-machine direction of the entire sandwich. Entire roof membrane. Not just the ply, not just the adhesive, but when I put those 3 plies in that adhesive, what happens? How much does it give me in tensile, and how much does it fall me? It's a very, very important topic. They determined that the minimum number, as you heard JD said, was 200 pounds of tensile strength. Right? So, Restoration 1.0 and you're doing a resaturant on top or a new top floor. I think the best way I always think of that, if you've ever seen the movie Shawshank Redemption, that's Andy Dufresne on the roof at the bottom, right? They're retarring the roof, that's a reset, right? So that roof better have at least 200 pounds of tinsel across the sheet to make that happen. Summary slide, and then there's just one more after this. So again, just wanted to bring to your attention that there is a shift happening right now, and those two challenges of the roof being too wet and too weak are now legitimately able to be overcome. There are solutions for that. If you don't have data for your restoration projects, I'm sorry, wrong strategy. I'll pick on you guys a little bit because I think when JP asked the question, how many people did roof restoration? A handful now. And then he also asked the question, how many people have seen diagnostics? And there's only a few hands up. I don't know, you guys maybe it's getting close to lunchtime, I get it. That scared me a little bit though, to be honest, because it's not only about like one method of diagnostic, it's multiple, right? And putting them together into a combination. These challenges that we talked about, whether it's logistics, raw material shortages, everything that's going on, it is unfortunately the new norm. And I don't know if anyone's ever tuned in to the inter-city town hall meetings. There was one last week or 2 weeks ago, and you get to hear the presidents of all the different manufacturing companies talk. I mean, again, I hate to be negative, but they're saying 2022 is going to look just like this. And it has to, because like you said, we already have lead times on materials that are 12 months out, and it's October. So it's not going anywhere anytime soon. JB, I think, covered all the benefits of restoration, so I leave you with what's next. Like, where do we go from here in this world of craziness? And Marcy talked a little bit about it, and JB did as well. But this idea where we take a step back, we're not just talking about roofing, we're talking about a building, but we're talking about restoring the entire building, and doing so from a performance-based approach. I know on the right it shows warranty, and having a whole building envelope of warranty is a pretty cool thing. But what I'm suggesting is we're going to get even beyond that, right? The warranty is great, it helps the owner sleep at night, right, that kind of thing. But how is this building actually performing? How does it compare to what we tested in the test facility? And I think that is really important in where we're going to do things. So JB's information is up there, mine as well. I don't get out much these days. I'm pretty much locked in my office in Chicago, so I appreciate you guys having me. If you want to learn how to do pocket square folding, I'll be available afterwards in the hallway. Just let me know, it's kind of my jam. Thank you for having us, we really appreciate it. We'll take any questions you have.
Supply chain issues, we were talking about restoration is a good solution because of that. Is there not supply chain or less supply chain issues with
So it depends on the technology, right? And JB hinted at what's going on with China with silicones. MDI and polyol are used to make polyurethanes, but not to the quantity of polyurethane, right? So depending on the urethane chemistry you're using, there may be a lead time. I'm talking weeks with a certain urethane restoration material, but with polyiso insulation, it's months, if not a year.
So it's more the installation for the stuff.
Correct. Now again, it isn't like it was a couple years ago, like on a large project, the buckets aren't going to ship tomorrow or next week, it may be a couple weeks, but that lead time still doesn't come close to what it is for moving purposes.
Yeah, so, I mean, the installations have been just phenomenally effective, and also the light gauge sheet metal, so the installation blades and the fashion, right? So some of the components you just can't get right now, and they are just so dependent, but some of them, we are doing better, just blanket statements, and we're doing a lot better for a couple months on our restoration stuff, where we might be 8, 9, 10 months to a year for other components, like ISO and fasteners and plates and stuff like that. It's just how it crumbles out, but, it is better, supply chain is better for restoration than it is for replacement material, even though I do some of the same stuff.
No, I appreciate the question. About that time?
So what are you recommending on like new projects, new buildings, because of alternative roof systems?
Well, interestingly enough, we're doing better on our asphaltic things than we are in more of our more synthetic, right? So synthetics, which gets into a lot of simplified, TPO, PVC, KE, PDM, right? So we're doing, those seem to be pushing out, you know, like months. Some of the supply chain is impacted. One, some of the raw material production for some of those materials has been reduced by 20%. On top of the fact that you just can't make it, you can't get stuff out and produce. The asphaltic materials are doing better. So we're doing better in modified, we're doing better in more traditional older school type systems than we are in the synthetics.
Yeah, I think to add to that too, I'm seeing contractors switch to EPS, which can be a tricky thing in some roof systems from a codes and approval standpoint. And then also looking at other materials which traditionally were available, like mineral wool, like you could just build the insulation system with that, but that demand is going up, so now you're waiting for that material. So I think an alternative could be EPS with a gypsum moving forward. But to David's point, it doesn't matter if it's EPDM, TPO, or even something like plastics, those lead times have gotten really big now. Whereas asphaltic systems we're seeing don't have that lead time. But that also depends on the reinforcement spread. Some of the fabrics, like polyester, do have longer lead times. So you may find yourself with a fiberglass reinforced sheet, which is a great sheet.
Some manufacturers aren't even making, they just said, we're not making any orders for sometime in the first quarter. Don't even place the order for another 6 months. And you know it's just going to be another 6 months from there, right? So it's just, I say, it's every week is a new horror story. There's a new chapter in the book somewhere, or something new popped up somewhere. It seems to be just constantly changing perspective, but the synthetics have been hit harder, and the replacement stuff has been hit harder for sure than the restoration stuff. Gary, I know you want to wrap this up. Thank you. Bob and John, thank you again for coming. Appreciate it.
You're welcome.
We have a half an hour break. Make sure you sign the clipboards in the back. Half an hour when we meet over in the ballroom. More than likely,